Hey guys, so this video lesson is going over the Unit 5 study guide. Please make sure you have it open so you can be looking at your work or following along with me as we go. Alright, so this first one says Derek is riding his bicycle with a 36-inch diameter wheel. So that's going to be an important number for us. He's riding it in a 10-mile race. They want us to find the circumference and the area of the wheel. So really that 10 miles means nothing for us. Okay, that doesn't play a role in finding circumference and area. First, let's talk about our formula. So circumference, remember, is pi times your diameter, and area is pi times your radius squared. For this problem, they say to use 3.14 for pi. So when I plug this in, let's do circumference first. Circumference is going to equal 3.14 times my diameter, which is 36. Type this in your calculator. You should get a circumference of 113.04 inches. Same idea for area. We have to substitute our numbers. We're still using 3.14 for pi, so area equals 3.14. Now, it's our radius squared. Remember, a radius is half of our diameter, so our radius here is going to be 18 inches, which I got that by doing 36 divided by 2. So, back to our formula, 18 squared. Do 18 times 18 first, then multiply it by 3.14, and you should get 1,017.36 inches squared. And remember, it's inches squared because it is area. So let me circle our final answer, circumference and area. All right, same idea. They give us a circle on the side. We have to find circumference and area of the circle below. They do tell us to use 3.14 for pi. So circumference, remember, that is pi times our diameter. So let's substitute our numbers. 3.14 times our diameter. In this image, they only give us our radius. Remember, a radius is halfway across the circle. So we have to multiply that by 2 to get our diameter of 28. And that's the number we'll use in our equation. Type that in your calculator. You should get a circumference of 87.92 inches. Same idea for area. Area is pi r squared. So substitute 3.14 times our radius, which they give us in our image, 14 squared. Multiply 14 times 14 first, then multiply that by 3.14, and you should get 615.44 inches squared for your area. Next slide is all about vocabulary. It says name the relationship of the angles shown. So if you take a look at this first one all the way on the left, we have angle A and angle B. I like to use the highlighting tool to show what two angles I'm looking at. When I do that, you can clearly see these two angles are directly across from each other, so they are what we call vertical angles. Just a reminder, vertical angles are equal, right? So if angle A is 30 degrees, angle B has to also be 30 degrees. The middle angle right there, again, I like to highlight what I see, what two angles I'm talking about. When I do that, you can see these are as well, but these are also vertical angles. They're right across from each other. And then the third one on here, we have intersecting lines right there, and these angles are across from each other. So all three of these happen to be vertical angles. Continuing with that vocab, looking at this next one, again, I like to highlight what I see, what two angles I'm looking at. So I have angle A and angle B. You can clearly see that those two angles combined create a straight line. Straight line is 180 degrees, so these are supplementary angles. Okay, remember supplementary equals 180 degrees. Next one, I'm going to highlight, there's my angle B and angle A. Those two angles together create a straight line, or 180 degrees. So these are also supplementary. Then last but not least, we have angle A right here and angle B right there. In the little corner, we see our box, which tells us this is a 90-degree angle. Two or more angles that create 90 degrees are complementary. So these should be complementary angles. All right, this next one, find the measure of each angle listed below. So we're finding the measure of angle 1, measure of angle 3, and measure of angle 7. Let's look at angle 1 first. So that is right here that we're looking at. So the measure of angle 1 we can clearly see is directly across from the one angle they do give us, which is 130 degrees. So you can see that 130 degrees and measure of angle 1 are vertical angles, which means they are equivalent. So measure of angle 1, no work to be shown. That's just going to be 130 degrees because of my vertical angle rule. Next one, measure of angle 3. So that's this angle right here. So you can see that, again, we're using that 130 to help us, but we have a straight line between those two angles. So 130 and angle 3, those two added together create a straight line. So when I need to find the measure of angle 3, measure of angle 3 is going to be 130 degrees plus, I'll just use x for my missing angle. It's going to equal 180, right? A straight line, 180 degrees. When I solve that, do 180 minus 130, and you get x equals 50 degrees. So the measure of angle 3 is going to be 50 degrees here. Last one, the measure of angle 7, so that's this angle right here. Well, we just found that the measure of angle 3 right here is 50 degrees, and that is a vertical angle with angle 7. So vertical angles are equal. That means the measure of angle 7 is also 50 degrees. All right, next ones are still working with vocabulary. This time we're talking about different types of triangles. So we are identifying each type of triangle based on its sides and its angles. Remember, sides would be like scalene, isosceles, equilateral. Angles would be right, acute, obtuse. So looking at this first one, we have, let's do angles first. So looking at my different angles, I have 90 degrees, 28, and 62. That 90-degree angle right there automatically tells me this is going to be a right triangle. Based on its angles, as soon as you see 90 degrees or that little box in the corner, sometimes that'll be there, that tells me it's a right triangle. Next, we have to look at the side measurements. So we have 8.8, 10, and 4.7. Because all three of those are different, that makes this a scalene triangle. All right, let's take a look at number 2. Angles first. So we have a 60, 60, and 60 degrees. So all three of my angles are less than 90 degrees. That makes this an acute triangle. Remember, an acute angle is less than 90. If all three of your angles are less than 90, makes it an acute triangle. Next, we have to look at our side lengths. We have 12.3, 12.3, 12.3. All of them are equal, which makes this an equilateral triangle. All right, last but not least, let's look at our angle measurements. We have 35, 35, 35, and 110. So we have two angles that are less than 90 and one that is greater than 90. The moment we see one of those angles greater than 90, we know it can't be acute, can't be right because I don't have a 90-degree angle. That has to be an obtuse triangle. Remember, an obtuse angle is greater than 90, and only one of those angles has to be greater than 90 for it to be an obtuse triangle. Next, let's look at our angle measurement, or our side lengths, 3.1, 3.1, 5.1. Two of our sides are the same. That makes this an isosceles triangle. All right, the next couple of slides say find the value for x and then the measurement of each missing angle. So here we have angle A, angle B. They give us different expressions for each angle. First thing we have to do is solve for x. We cannot find either of those angle measurements before we have our value for x. So take a look at the two angles that we have. Here's angle A, here's angle B. Notice they create a straight line, which means both of those angles added together will equal 180 degrees. We can use that to set up an equation and solve for x. So angle A, 5x plus 10, plus angle B, which is 6x plus 5, both of those angles added together should equal 180. Now this is just an equation we can solve. Before you can start to actually solve for x, you have to combine like terms. So we have 5x and 6x, add those together, you get 11x, and then 10 and 5 added together is 15. Remember, you cannot just combine 11x and 15 there. They are not like terms, okay? 11x has an x with it, and 15 is just a constant, okay? So that number needs to stay solo. All right, we have 11x plus 15 equals 180. I'm going to draw my line, and now I can solve. So subtract 15 from both sides. Get 11x equals 165. Divide by 11. Divide by 11. Should get x is equal to 15. Now we can use that x value to solve for the measure of angle A and the measure of angle B. All right, let's solve for the measure of angle A first. Measure of angle A was 5 times your x, which I'm going to substitute, 15 plus 10. So the measure of angle A, 5 times 15 would give me 75. 75 plus 10 tells me the measure of angle A is 85 degrees. We're going to do the same thing for the measure of angle B. Measure of angle B was 6 times your x, which we'll substitute in 15, plus 5. Multiply first. So 6 times 15 is 90. 90 plus 5 tells me the measure of angle B should be 95 degrees. Now remember, you can always check this. We said in the very beginning that adding together measure of angle A and measure of angle B should equal 180 degrees. Well, 85 plus 95 gets me my 180. So you can always check your work to make sure you got the angle measurements correct. All right, next one, same idea. We're solving for x first, then solving for our missing angles. If you notice, these two angles combined create a straight line, which means when I set up my equation, it's going to equal 180. So angle A, x plus 27 plus angle B, which is 2x, those combined have to equal 180. Combine like terms first. We have x and 2x gives me 3x. There's nothing to go combine with my 27, so just bring it down. Now I'm ready to solve. Subtract 27 from both sides. We should get 3x equals 153. Divide by 3, divide by 3. X is going to equal 51. Now we're going to use that to solve for the measure of angle A, which was x plus 27, so 51 plus 27. The measure of angle A would be 78 degrees. And then measure of angle B was just 2 times our x, so 2 times 51. So the measure of angle B would be 102 degrees. Remember, you can always check it. 102 plus 78 would get me my 180 degrees. All right, that is part 1 of this video. Please go back to the agenda or unit plan and click part 2.